went out like only like half the class was here,
Oh,
and so it was like kind of a special.
I have mine still at the house.
that looks like really good water. Where'd you get it?
So when you multiply same base, you add. So hopefully everybody was successful in completing number 1. B to the 10. And now we'll divide. So 6 divided by -3. You've done that a lot. Same as it's always been. -2. Any questions about number 2? Yes. So I had 1 up top and 2 down below. So when they cancel, the 1 that's remaining is in the denominator. Okay, who else has a question? Okay. So number 3 we covered on Friday. We did it really quickly. We didn't spend a whole lot of time on it. But we did practice subtracting complex numbers in chapter 4, so you just, distribute this minus sign and combine like terms. So this I rewrote as a minus, and this became a plus because a -1 times a negative will make it positive. Now I'm going to search for anything that is a like term and combine it. Looks like, yes, 10 and -5. B squared and 2b squared. And when you combine like terms, you don't change exponents.
Yeah.
How is it?
It's so funny. I would literally
So that's going to be a positive 5a squared plus 3b squared minus 6ab. Notice that none of the exponents changed, only the coefficients. No.
Wait, so what'd you do? Wait, what'd you do, Miss?
This is the answer to number 3. You said it out loud. I did the, yeah, come on. Yep. All right, so 4 is distribution, and then in 5 we discussed on Friday and have not discussed since. So if you were absent and you did not watch the video, then you might not know what a degree is. Even if you were here, you may not remember. Try. Are you guys good if I erase 3? Okay, so I'm going to distribute. Boom. And boom.
Are you distributing 7?
Both of them together. When multiplying, you add exponents. So we're at 14 w to the 3rd. So w1 times w2 makes W3. Okay. Plus 56W squared minus 35W. It's the exponents you gotta check. Mhm.
That's the final answer.
Yeah, nothing else you can do. So on Friday, we talked about degree being the highest sum of exponents in any term. So to kind of get your eyes right, this is the first term. So you would add those exponents together. And this is your second term. Third term. Fourth term. So when you are asked to find a degree, you add exponents on the variables. So like the degree in the first term is 3 because it's x to the first and y squared, making a degree 3. The degree in the yellow one would be 5, and then that would be 4, and then the degree of this is 0 because there's no variable at all. So the degree of the polynomial is 5 because it's the highest sum in the list. So this one had a 5, so the degree of the whole thing is 5. So the degree in number 4 is 3 because that's the highest exponent in the list. So these 5 problems review everything since last Friday. Obviously, with those rules of exponents, there's so much more we could discuss. So 1 and 2 cover rules of exponents just a little bit. Number 3 is combining like terms. Number 4 is multiplication, and number 5 is this vocabulary word degree. When you're done with that, just get out your homework so you can check answers.
Does it matter the order of the exponents? Like if you're distributing in an exponent.
What number?
30. I put negative 3 VP.
Technically, this one is a degree 3 and this one's a degree 2, so you're going to see the higher degree first.
Oh no, I'm not talking about the degree. I'm talking about I'm talking about the variable.
The variables typically should be in alphabetical order. Yes, do it right now.
Negative 8 cubed.
P5, C3. Oh, 18 there. If you were planning on coming by after school today for makeup work or any questions, please let me know right now so we can work it out.
How did it get to it was that quiz, open, not open up quiz, but over quiz. We gotta do that. We'll figure it out. Yeah, I just can't find it. That work. Oh, what? Sunday morning? Tuesday. Tuesday night. Or Tuesday afternoon. I'll be home until. I'll come back to Friday after Thanksgiving. Gym will only be on the weekends. How do we do that?
That's a question. Wants to see Andy's work.
Can you do 29?
Yeah, 32. I really haven't even I haven't even done one of these with you. So. I would think the majority of questions came like 30 through 30. I would practice them. So I got 7 A's over 5. Five B is over 9 B's. And on the C's. Yes, because 9 over 18 has always reduced to be 1/2. So that 2 has to be the denominator. So 9 goes into 9 once and 18 twice. And I got 5 A's over 5 A's. So that's 2 A's remaining in the numerator. And I got 5 B's over 5 B's. So that's 4 B's left over. 3 C's over 3 C's. So 1 A squared C squared over 2 B to the 4th. So writing it out isn't always feasible, but it does kind of help you understand, where the difference comes from. What was the next one? 32. So distributing a binomial into a trinomial. I think this might be a perfect cube. Yes, graph. Oh, no, not a perfect cube. Alright, so x times x squared will be x3, because there's an invisible 1. When you multiply same base, you add exponents. X times 2xy would be, the 2 stays the same. X times x is x squared. And then the y stays the same. X times y squared. Just jam those right next to each other. Xy squared. Do the same thing with the negative y. So I think this was kind of Torian's question. I could write this negative yx squared or negative x squared y. Technically in alphabetical order is best. So I'm curious if you did this yourself, if you did the work yourself, who has their y first and who has their y first? Thumbs up. Who put their x first? Oh, yeah. Okay. So It doesn't matter, I'll give full credit to either one, but so you know, the technical rule is to put it in alphabetical order. X squared y. Negative y times the middle term would be negative 2xy squared. And negative y times y squared, negative y to the third. Combine like terms. So when I get to this one, I see which one has x squared, and it's this one. So 2 take away 1 will be 1x squared y. Nothing changes but the number in front, the coefficient. Now I got 1xy squared minus 2. Leave me with a negative 1. Minus y to the third. Any other questions? With that big distribution and all those powers. Do you guys want a minute to do 33? So okay. What are you doing though? You're doing both of them here first. X and then Y. Oh, you tried putting it in order. Yeah. Technically, these all have a degree 3. Degree 3, degree 3, degree 3, degree 3. So the reason they're ordered like this is because the X comes first in the alphabet. So that's why the order comes from. All right. So we're gonna move from simplifying, adding and subtracting, multiplying. This is multiplying. To today we're gonna start dividing polynomials. These are all called polynomials. All right, so we're on 5-2. I think we're gonna do 4 examples. I think you'll find this one of our the problems aren't as long as some of the problems we do. Let me just say that. I don't want to say that they're simple or anything like that, but yep. So heads and tails, I think we do 4 examples and we're done. You guys probably won't have homework. That's what it's looking like to me, yeah. I don't know. I guess I shouldn't have said that. I don't know how long these are gonna take you.
Depends on if we get it or not.
Yeah. Some people it won't take long. Some people will take longer. Yeah.
Dude, I have to do my homework.
So everything that we've done has been in chapter 5-1 since Friday. So that assignment that you did in the textbook, that was like a full review of Friday, Monday, and Tuesday's work. Today we're starting 5-2. So if you weren't on board on Friday because you were not here, you didn't do it on Monday, and yesterday you just copied those answers, you missed 5-1 completely. You might want to read it and try to figure it out. I'm just saying if you didn't do yesterday's assignment yourself and you really didn't participate Monday and you were not here Friday, you've missed an entire section of the curriculum. No, we are. The whole chapter's exponents. So the first section's on like simplifying, adding, subtracting, multiplying. This one's just dividing. There's 3 types of division we do. Today's work will be this first star. Dividing a polynomial by a monomial. And then we'll work on long division for like 2 days. And then we'll work on synthetic division for like 2 days. So these take kind of a hot minute to figure out. Yeah. I mean, long division, you probably don't even remember how to do. We're going to do long division with variables. Synthetic division is an awesome shortcut that you'll like when you get the hang of it. I do recommend that you read the book. And I will be posting some Khan Academy lessons on that. Alright, are we good? Ready to go back? Alright, so here's our first example of dividing a polynomial by a monomial. So this is a polynomial. You got all these a's and b's, the exponents. There's 3 terms in the numerator, and this is called a monomial. One term. You guys know what the prefix mono is? What? So poly is many. So many terms divided by one term. Polynomial divided by a monomial. So my only simple directions are to separate and then simplify. Make sure you've had time to write the problem down before I start.
So by separate, are we just putting each term of the polynomial under 5AB?
Yeah. Alright, separate this. This is good for like fraction practice anyway. Do 5a squared b over the denominator minus 9 over the denominator. You got a question, Max?
No. I was just saying, when you said it's separating them, I just didn't know how you said it. I just literally said it.
Separate it. And so we're making 3 separate fractions. Each term of the polynomial goes over the monomial. And then you break them down step by step. Very similar to simplifying like we've been working on. So in the first part here, the 5's would cancel. We got a squared over a, so that'll leave just an a on top. And the b's cancel. So this first little guy reduces to just a. We have 2 a's over 1 a, just a. Now we'll reduce the second one. Minus 1. 15 divided by 5 has always been 3. 5 goes into 5 once, and 15 3 times. A's cancel. We got 3 b's over 1 b, so I got b squared left over. Alright, and then the third one, plus sign. 10 divided by 5 has always been 2. A squared be the third. Wait, can't wait anymore. I'm gonna leave it just like that. That's your final answer. Let's try it on. Jackson, there you go. You got this one right? He's on his phone.
Is it the same?
Or just like that. Don't peek until you're finished. So the next two are the same thing, but they visually present differently.
Wait, what?
Yeah, look at it. Visually, it looks like a completely different problem, but it's the same thing. It's this whole thing divided by a monomial. And so this is horizontal division, and a fraction is vertical division. So go ahead and write it as a fraction, and then separate it. Same problem.
So,
Focus on one at a
so just
time.
do what we've been doing for the last two problems.
Yep, same thing. You're gonna write it as a fraction instead of a horizontal division problem. Yeah.
Do we leave a plus one?
Yeah, as long as CDS. I'm getting three variables. This must be like about a three-dimensional problem. Some sort of volume. A volume is length times width times height. Leaving a chance of having three unknowns, three variables. So volume formulas sometimes lead to three variables like this.
What if a numerator can't be evenly divided by the denominator? Like what if we
You
had
can have a resulting fraction. You haven't yet, but you can have a fraction in part of it.
or
All right, so I got my first one done. Yes. Sure, go for it. What'd you get for the second one? We're gonna put a 1 at the end. Anytime you have a monomial over its exact self, you put a 1 placeholder. Great job, you guys. You love it. I knew you would love this topic. Well, it's a little bit less work than a lot of the problems we've done. There's less steps to remember. You honestly, you don't have to remember anything. You just have to do it. Separate and do it. Last one. So I'll put this on the chapter 5 test. That doesn't happen for weeks, and you won't get it. It's very sad. You just don't remember how to do it. It's the exact same problem. It's just like 1 through 3. Remember that negative exponents lead to fractions. Okay, so this presents differently, but it's the same problem. If I put this whole thing over 1, because that has a negative exponent, I would circle it and move it down to the bottom of the fraction. It's always so sad when people can do the first 3 and they get to this one and they leave it blank. Yeah, it's only 2. And I think to myself, boy, that was the same problem. They just didn't know what the negative exponent did. So I take this and I put it underneath the first polynomial and then separate it. question answer. Anybody else? Anybody else get this? All right. All right, so all 8 of your homework problems are like this. So you guys got 14 minutes. I think you could probably finish it in class and leave without homework today. Don't rush, but I'm just saying get to it.